Okay, so hi students. Till now we were discussing about Dirichlet integral and we saw two cases of Dirichlet integrals, the fundamental form of the Dirichlet integral. And I told you that we will see more its extensions where we will see a family of Dirichlet integral. Okay, so let us see how can we derive a family of Dirichlet integrals from this basic Dirichlet integral which I told you in the previous video. Okay, what I told you that in order to obtain those other form of the integral, other integrals, what we need to do is that we have to integrate this integral with respect to beta, this variable with respect to beta from 0 to some constant. Okay, so let us do that and see what the form we obtain. So if we want to integrate this integral with respect to beta, what will happen, let us see. So what we want to do is 0 to some constant c d beta of 0 to infinity dx sine beta of pi x. So we want to integrate this pi by 2 epsilon of beta d beta from 0 to some constant c. Okay. So here when you are doing the integration with respect to beta, you have to treat the x as a constant and you need to change the order of this integration. Then the integration of sine beta of x, sine of beta x will become minus cos of beta x divided by x. So this will become cos of beta x divided by x, and there is another x, then it will become x square, and there will be a minus sign, and the limit is from 0 to c. This is the limit of beta, the integration over 0 to infinity dx. Okay, so this is pi by 2 epsilon beta. This is a constant function. I told you in previous video what is the form of this function. This function look like epsilon of beta has the form like this. Suppose this is beta axis and this is like this. So this is minus 1, this is plus 1. So this is the form of this epsilon of beta. This is the function. Okay, so let me remove this part here. So this becomes here. So this is a constant function and you do the integration from 0 to c. So this will become epsilon of c and c, this, and you can write it like so. C epsilon of c is nothing but mod c. You can check it by putting, so if you are in the positive range, if you are positive side, then this will become only c. If you are in the negative side, so epsilon of minus c will give you a minus sign. This will become mod c is equal to minus c. Okay, so you can write it like this, mod c. So here we are going to put the limit for the beta, and this will become, so since there is a minus sign, we can change order of the limit. So let us put first beta equals to 0, then 1, then we will put cos cx divided by x square. This is the integration from 0 to infinity dx equals to pi by 2 c epsilon of c. So are you clear about this? So we found the another form of the Dirichlet integral. So let us more simplify it. So if we want to simplify it, we can write the formula cos cx equals to 1 minus 2 sine square cx by 2. We can use this formula. So if you do this manipulation here, sine square cx by 2 is equal to minus 1 minus cos cx divided by 2, correct. So if you put this form in the above integration, this will become 0 to infinity. So this will become 2 sine square cx by 2 divided by x square dx equals to pi by 2 c epsilon of c. Now you see here that you can replace here c by 2 by some another constant. So you can replace it by c prime. So what you can do is that you can replace c by 2 by c prime. So if you do so, you will see here. So if you replace this c by 2 by c prime, you are not going to from positive to negative side, you are in the same region. Either you are in the positive side or in the negative side. So both have the same sign, c prime and c, okay. So here sine square cx by 2 will become c prime x divided by x square. This is pi by 2, and this 2 factor you take on the right hand side, that will become c prime, and this is a constant function, so this will become epsilon of c prime. So this is 0 to infinity dx. So this is another form of Dirichlet integral. So first form of Dirichlet integral we have this one, and this is the second form of the Dirichlet integral, correct. So let me write down the number. This is first one, this is second. Both are not the same integral, both are the different integral. You can see here that in the first form of the Dirichlet integral, it has in denominator we have x, the single power of x. In the second form you see x square, but as you saw in previous video that sine of x divided by x at x tends to 0 has finite limit. In the same way here sine square c prime of x by x square also has finite limit at x tends to 0. Okay. Now again we do the integration with respect to c prime from 0 to some constant, and we try to evaluate another form of Dirichlet integral. So let us see that also. So here you do the integration with respect to c prime here again. So let us do that, and you do the integration up to some finite constant. You can write it like this also, because these two have the same value, because we have replaced on both sides, on right hand side and on the left hand side. You don't have to confuse that I have changed the value from c prime to c again, and so you think that we have returned to the previous integration. So the form is same, the value is same, correct. Now we will do the integration with respect to c again, or you can write it in the form of beta, that will be good, and you do the integration from 0 to c. So again we will do the integration with respect to beta from 0 to c d beta, okay. If you do so, you will get a third power, a cubic power in the denominator for this integration, and what the form you get is like this, 0 to infinity dx by x cube. When you integrated first time you got x square, when you are going to integrate second time you are going to get x cube in the denominator, and the form is like this, sine cx minus cx is to minus pi by 2 c square by 2 factorial epsilon of c. So this is when you do the second time integration, correct. So let me tell you one more thing. This is third equation, third Dirichlet integral. This is the second Dirichlet integral, this is the third Dirichlet integral, and the first one we have already seen. In each case you will notice one thing. So this is the second one, this is the first one, and it has this form also. Let me highlight this. So this is also second form. These two are same, just what we have done here, that we have written it in terms of sin square x. So thus you see here that we have three Dirichlet integral. First one is this, which have the integrand of sinc function. This is the second form of Dirichlet integral. These two integral are same. They have different representation because one is in the form of cos, another is in terms of sin square. This is the third Dirichlet integral. If you integrate this again, what you will get? So you are going to get here, if you are going to integrate with respect to this constant parameter from 0 to some constant, you will get it x to the power 4 1 minus c square x square by 2 factorial minus cos cx equal to minus pi by 2 c cube by 3 factorial epsilon of c. So this is fourth Dirichlet integral. Okay, so see here the pattern. The first one has integration which has the function of function of sine. Second one has the function of cos. Then again in the third you see the sine. Again you see the cos. So what is the form you are seeing here? And you are seeing is that integrand function is the function of cos, but what is subtracted from this cos is also a first few terms of the cosine series. In case of sine, you see that what is subtracted from this sine is the first few term of the sine series, correct? So if you keep on integrating with respect to this constant parameter, you are going to get sine and cosine integrations, and those integrand will be subtracted by the first few terms of the sine and cosine series respectively. So in this way I am going to generalize this pattern for the nth integration. So if you keep on doing this integration with respect to that constant parameter, what you are going to see is that I am going to tell you here 0 to infinity. So you will see here this integrand will be like sin c of x minus, and this will be subtracted with the some few terms of the sine series. So 0 to n minus 1, you have to write the general term for the sine series. So if you do the integration n times, you are going to get this integration. So this is the first n minus 1 term of the sine series, and this is sine of x, sine of cx, and if you are doing the nth integration, so you are going to get this Dirichlet form of the integration. Okay, if you do the again one more integration, so alternately you are getting sine and cosine integrands. So here if you do the integration, if you are going to get cosine series, that will be n minus m minus 1 term will be subtracted of the cosine series. So you get these two form of the integration. So here what is the moral of the story? That if you start from the fundamental Dirichlet integral in the form of sinc function, which have the integrated exactly the same function, and you keep on integrating with respect to that constant parameter beta from some 0 to some constant, you are going to get the different Dirichlet integral which have the integrand in terms of sine and cosine function, and those sine and cosine functions are subtracted by some few starting term of the sine and cosine series respectively, correct? So as you are seeing here, and you will see in each integration that the power in the denominator will keep on increasing. First in the sinc function you saw that the power was 1 by x or single power. when you do the integration again, you see that power increases x square in denominator. If you don't look very seriously, you will say that there is a divergence at x tends to 0 because x is in denominator and x tends to 0, the denominator tends to 0. But this is not the case, because in numerator you have the sine and cosine series, and that whole integrand tends to a finite limit as x tends to 0. So, as you can see here in the left hand side, as x tends to 0, the limit is finite, because the numerator is some sine series divided by some x to the power 2n plus 1. Similarly for this, so the limit is finite. One more thing you will notice, that as n tends to infinity, not x n, as n tends to infinity, the first few terms which are you are subtracting from this sine function, these first few terms which you are subtracting from this sine function, as n tends to infinity, this series exactly is this sum is exactly equal to this sine function, and this cancel out and give you 0. And you can also see in the right hand side that n is in the denominator. So, if n tends to infinity, this right hand side part also tends to 0. Similarly, you can see in this the cosine series also, as n tends to infinity, m tends to infinity, this sum become equal to this cos function and this integrand becomes 0. Similarly, you see in the right hand side. So these are the two general form of the Dirichlet integral which you obtain from the basic sinc function integration. Okay. So now this part, Dirichlet integral part, is over, and from the next video you will see that I am going to start some special functions. Those special functions you will be using very much in your physics syllabus. So these two integrations, this Dirichlet integral, you will find in the random 5 probability theory. So if you keep on watching this video, you will find this application of this integration in the further course. Okay. So thank you very much.